नमस्कार दोस्तों, welcome to channel Toxicology on board. Today in this video we'll discuss another DABT topic, that is the rate of oxidation of ethanol. So a couple of videos we have already discussed about ethanol. Today we will discuss about ethanol toxicity with respect to polarity. Okay, the structure, polarity, electrons, those things we'll discuss. This question is taken from ABT recertification examination May 12, 2000. The question is rate of oxidation of ethanol in the body is proportional to. So we need to identify how the rate of oxidation is related to these options, whether it is directly related or inversely proportional. So rate of oxidation of ethanol, it is proportional to the blood ethanol concentration. So whatever the concentration of the alcohol in our blood, is it directly proportional to rate of oxidation? No. Rate of oxidation can be accelerated significantly by administration of oxygen. See, when you are administering oxygen, when there is hypoxia condition or the hyperbaric oxygen, that kind of treatment will be there, no, in that case only. So here, increasing administering oxygen will increase the rate of oxidation of ethanol. No, it is not related. This particular concept can be accelerated. Rate of oxidation can be accelerated significantly by vigorous physical exercise. No. Whether a person takes alcohol and he does exercise, and that is if it is related to the oxidation of ethanol, no. Okay, the rate of oxidation is equivalent to 10 ml ethanol per hour. This is the right option. Why this is the right option, which was given by the our previous DABT students, is that from my seniors, is that ethanol follows first order elimination. Okay, so there is a trick with respect to ethanol elimination. No, it follows both first order kinetics as well as it follows zero order elimination as well as first order elimination. So what is the concept behind this particular rate of oxidation of ethanol, its elimination, we'll discuss in this video. Okay. So ethanol typically follows zero order kinetics, that is constant rate at high blood alcohol concentration. Whenever the alcohol concentration in your blood is in very high level, no, at that time alcohol is acting, which is following zero order kinetics. Means whatever the amount of alcohol you take, the same amount of alcohol will be eliminated from your body. So it is constant rate. But this there will be shift. See, this is the typical graph which from which you can see. Initially, alcohol is following zero order kinetic. A constant amount of drug is eliminated per unit time. That is the principle of the zero order kinetic. That's why you can see the graph. The amount of alcohol which you administer is equal to the amount of alcohol eliminated from your body. Okay, later on, this particular graph will shift. The zero order kinetic, zero order elimination graph will shift towards first order elimination. Why? Because there is a saturation of this particular enzyme called ADH. Okay, that we will see. So, but shift to first order elimination, rate proportional to concentration at low concentrations. Whenever the BSE, blood alcohol concentration, decreases to 20 to 3 mg, 30 mg per dl, no, then zero order elimination will change to first order elimination. In this phase, the elimination rate slows as blood level drops. Okay, as the enzyme alcohol dehydrogenase is no longer saturated. So this is a concept you have to remember. Try to pause here, try to read the example and this particular graph, and what are the key aspects that one we can learn with respect to first order ethanol elimination. Concentration dependence. Okay, unlike the standard constant rate, that is 15 to 20 mg per dl, first order elimination means the rate of elimination decreases as the blood concentration decreases. This is the thing here. You can see the graph. Okay, the shift to first order kinetic generally occurs when blood alcohol concentration falls below 55 to 65 millimole per liter, or roughly 25 to 30 mg per dl. Here also that is what they get, less than 20 to 30 mg per deciliter. Okay. So what is the mechanism? Why there is a shift from zero order elimination to first order elimination? While the ADH, that is alcohol dehydrogenase enzyme, usually operates at maximum capacity. Okay, whatever the amount of alcohol which you do, it gets metabolized by this alcohol dehydrogenase to acetic acid. A lower concentration allow for non-saturated enzymatic metabolism, making the rate proportional to the amount of alcohol present in your blood. Okay, this is often observed in the later stage of elimination or after consuming small amounts of alcohol. Okay, so while the majority of the studies emphasize that zero order kinetics for forensic blood alcohol concentration calculations. Understanding the shift to first order at low levels is crucial for accurate pharmacological modeling. So this comes with respect to PBPK modeling is there, no? So we have to see when you're taking the blood samples and measuring the alcohol concentration, whether you have when you're calculating BSC calculation, whether you have to follow zero order kinetics or first order kinetics, that is very crucial for pharmacological model. So it's very challenging for the individual who is assessing the BAC concentration in that particular patient. In alcohol poses, now we are going to discuss about the chemistry with respect to alcohol. As I told you, no, toxicology is not a pure science. You need to be aware of chemistry also. So in my previous videos also I told you, I'll discuss about the polarity, why alcohol is widely used as an industrial solvent. What is the polarity? Uh, so alcohol poses OH group, that is hydroxyl functional group, which adds polarity to the molecule and makes alcohol highly soluble in other polar substances such as water. That's why alcohol is always consumed along with water because it is miscible. Okay, because of the polarity nature of this one. Why it is having polar nature that we'll discuss. Example, ethane gas. If you see ethane gas is C2H6, CH3, CH3. Two simple methyl groups are there. It is negatively soluble. See, straight chain alkanes you take, whether it is methane, ethane, propane, hectane, hexane. In biological systems, alcohols are generally they're causing CNS depressants, okay, but they can also act as a nucleophiles. Why nucleophiles? Because of the free electron negative charge present on the oxygen atom. Then ethanol may act with cocaine to form. That's why always there is a co-exposure. The persons who are consuming alcohol, they also use recreational drugs. For example, if that certain individual is consuming alcohol along with cocaine, no, there is a product called coca-ethylene will be formed in your blood. So ethanol may react with cocaine to form coca-ethylene, a longer acting and more vasoactive, more constriction of blood vessels will be taking place than cocaine itself. Okay, so there will be uh, synergistic type of effects will be there. This is a best example. It is there in the Clayson textbook also. This particular example. Alcohol can be primary, secondary, or tertiary. So how we are going to decide which type of alcohol, whether it is primary alcohol or secondary alcohol or tertiary alcohol, that you can decide it based on the addition of this hydroxyl group. Here you can see in the picture you have primary alcohol. Here one OH group is attached to the carbon, okay, and two hydrogens and one methyl group is attached. Okay, if two methyl groups are attached to the central carbon, it is secondary, and if three methyl groups are attached to the carbon, it is tertiary. So again, I'll tell you. Alcohols can be primary, secondary, or tertiary, in which the reference carbon is bonded to one, two, or three carbons in addition to the hydroxyl group. Here, in both primary, secondary, and tertiary, OH, one single OH group is attached to this primary, secondary, and tertiary alcohol, in addition to how many number of methyl groups are attached to the central carbon, that is going to decide whether it is primary, secondary, or tertiary. This is the concept you have to remember. Methanol, in which reference carbon is bonded uh, to no other carbon, is not a primary. For example, yes, in the case of methanol, what is happening? CH3OH. The carbon is attached to the OH group and three hydrogen groups are there. So there is no CH3 group attached to the methanol. But still, that methanol, no, it will try to behave. Its characteristic physicochemical properties are similar to that of a primary alcohol. So methanol, in which reference carbon is bonded to no other carbon, is not a primary alcohol per se, but shares many of the reactivity patterns similar to that of the primary alcohols. The difference between primary, secondary, and tertiary structure is important. Why it is important from the toxicology point of view? That we'll see. Because although the alcohol functional group imparts this OH group, whatever which is attached, no, it will show you some characteristics. Why this is very important is that when you're doing read across, no, group of chemical or class specific effect, no, in that this is very important. Functional motifs which are responsible for showing certain biological or toxicological effect. Okay, so OH group itself will add some reactivity to that particular molecule. In addition to that, imparts many qualities to the molecule. The degree of substitution can affect the chemical reactivity. Primary alcohols can undergo multi-step oxidation. Okay, so when there is a metabolism of this alcohol, action by this alcohol dehydrogenase, if in certain type of alcohols like primary alcohol, it will form acetic acid, whereas in the case of isopropyl alcohol, secondary alcohol, ketones will be formed. That we will see. See, primary alcohols can undergo multi-step oxidation to form carboxylic acid, whereas secondary alcohols generally undergo one-step metabolism and they form ketone. Okay, and tertiary alcohols do not undergo oxidation. So, based on the nature of the primary and secondary, the byproduct will be as such. The first step, all the alcohols will behave same. Once the toxic metabolite is formed, for example, in the case of methanol, oxalic acid is formed, which will cause blindness. Whereas in the case of ethanol, acid is formed, where it will cause anion gap acidosis. Okay, that we'll see. I'll try to explain. This is a point of significant toxicological importance and is discussed in more detail. Alcohols can be named in many ways. This you people read it on your based on which type of functional group it is attached. It is named. IPAC name, that is also important. When you are doing literature search, CAS number and synonyms, IPAC name, these are all very, very important. Otherwise, you will end up getting information on so much that you will not be able to um, able to identify the exact chemical on which you are performing the literature search. As noted above, molecules with given functional group often have more in common with molecules within the same functional group then they have in common with molecules from which they were derived. I think you will be getting confused here. Actually, what we need to understand is that initially, before addition of alcohol group, no, there were chemicals were alkenes, straight chain alkenes. They were methane, ethane, and propane. To which one OH group is added, methane became methanol, ethane became ethanol, propane became isopropyl alcohol. When you look into these alkanes, no, straight chain hydrocarbons, they all having similar properties. Remember the read across this thing for class specific effect. So all the straight chain alkanes, they are gases at room temperature, have no solubility in water, have similar melting and boiling point. But once you see ethane, OH group is attached, ethanol is miscible with water. Now we'll see. When these molecules are substituted with one or more hydroxide functional groups, primary alcohol, that is one propanol, and secondary alcohol, that is 2-propanol or isopropanol. Okay, each of these alcohols, no, they're liquid at room temperature and all are water miscible. They are soluble in the case of water. So just by addition of one functional motif, no, the physicochemical properties will change. The metabolism is changing. The toxic metabolites which are formed, multi-oxidation step, single oxidation step, some are forming acids, some are forming ketones. So because of which then toxicology of that particular chemical will change. Okay, for example, methane, ethane, and propane are virtually incapable of undergoing oxidation in biological system. These things, if even if you are exposed to methane, ethane, or propane, your biological system will not react to these particular straight chain alkanes. But alcohol formed by the addition of one or more hydroxyl group will readily oxidize by this particular alcohol dehydrogenase. Because to metabolize methane and ethane propane, we don't have these enzymes. These enzymes will not act upon this straight chain alkanes. Okay, so if you look into this, we have seen the figure 11.3, no? Oxidation of primary alcohols, methanol, ethanol will result in formation of aldehydes, okay? Whereas oxidation of secondary alcohol, that is isopropyl alcohol, results in formation of ketone. In the case of both aldehydes and ketones, they belong to carbonyl functional group only. But acids are behaving differently, ketones are behaving differently. That you have to understand. Functional groups in which carbon atom contains a double bond to oxygen and a single bond to hydrogen. That is in the case of aldehyde, CHO, CH, C double bond O it will be. Whereas in the case of ketone, no, a functional group in which the carbon is double bond means C double bond O to an oxygen atom and a single bonded to two separate carbon. C double bond O and another that C is attached to another carbon as well as another carbon. Two different carbons will be attached. Okay, so for this reason only, acids and ketones they will act very differently, and their adverse effects are completely different. Although both aldehydes and ketones contain carbonyl group, a carbon-oxygen double bond, aldehydes and ketones distinctly differ functional group and have different reactivity patterns in your biological system. Okay, for instance, aldehyde can undergo enzymatic oxidation to carboxylic acid. Ketones they cannot because ketones will undergo only one step oxidation process will be there. It is here that recognition of functional groups will help you to understand the potential toxicity of an alcohol. That's why I'm telling ethanol, metabolic, what is this one? Anion gap will be there. Okay, let's see. Then methanol, ethanol, and isopropyl propanol or isopropyl alcohol, all are alcohols. As such, their toxicity before metabolism, when they are in the first step, no, is expected to be same, quite similar to that of the ethanol producing CNS sedation. Okay, CNS depression will be there. Because these toxins are primary, secondary alcohols, all three can be metabolized to carbonyl compound, either to an aldehyde or ketone. However, the functional group on the molecule have changed. Okay, now COH is there, in one C double bond O is there. Whereas aldehyde can be metabolized to carbonic acid and ketone they cannot. Okay, that's why aldehydes will have anion gap acidosis. It is for this reason that methanol and ethylene glycol can cause anion gap acidosis, whereas isopropyl alcohol, that is secondary alcohol, will not cause anion gap acidosis. Methanol will give you formic acid, and that formic acid will cause blindness, okay, in the eye. That you have to remember. That's a characteristic feature of a methanol toxicity. Ethanol will cause okay, anion gap acidosis will be there. Then we'll try to understand how the metabolism of methanol is different in the case of primates as well as rodents also. So the concept of functional groups are very useful in order to understand. Particularly read across category, this particular thing is important. Okay, for a certain chemical for which literature is not available, we'll do read across, or grouping of the chemicals will be there. No, class specific effect will be there. For example, straight and alkane is there. For example, there is no if you have a literature for hexane, and for a certain chemical heptane, like 7 carbon straight and alkane, if you don't have any literature, addition of methyl group may not cause or not infer to severe type of toxicity. So hexane data can be used as a read across for heptane. So like that we'll be doing. So similarly, addition of functional group will be helpful in order to understand the toxicity of a certain chemical for which there is no literature available, but yet certain times they have, every process will have its own limitations. So what are those limitations we will see. For example, although both formic acid and oxalic acid are organic acids, they cause different patterns or organ system toxicity. For example, formic acid, what it is causing? It is causing blindness. The target organ is eye, whereas oxalic acid, the target organ is kidney. What is tubular cast will be formed. What is it? Kidney stones will be formed with the oxalic acid. Oxalic acid, when it comes in contact with calcium, it forms kidney stones. Okay, blockage of the tubules will be there. Okay, renal failure will be there. So we'll understand that how the two different acids are. Formic acid is a mitochondrial toxin, exerts efforts primarily in the areas such as retina. So it is targeting rods and cones in the case of eye, or basal ganglia that poorly tolerate an interruption in the energy supplied by the oxidative phosphorylation. You have to also understand, whatever your eye is there, no, it is directly getting the oxygen. Okay, when compared, this is the only organ, one or two organs are there in our body who are directly getting the oxygen, not from the blood supply. Okay, so because of which they do not want any interruption in the energy. If there is an interruption in the energy, then that will affect your rods and cones, retina as well as basal ganglia. So poorly tolerate any interruption in the energy supplied by the oxidative phosphorylation. This is very important. Okay, when you read about anatomy of the eye, you will understand. Conversely, oxalic acid readily precipitates calcium. As I told you, know, when it reacts with calcium, and is toxic to the kidney. In the kidney also, you have to understand which particular cells, that is renal tubular cells, PCT, will be there, no, which accounts for the hypocalcemia. There will be a decrease in the calcium levels. Oxalic acid readily hypocalcemia and nephrotoxicity that are characteristic of a severe ethylene glycol poisoning. So whenever you are reading about methanol, ethanol, isopropyl alcohol, you should also be reading about ethylene glycol. Ethylene glycol poisoning will release oxalic acid. Okay, the concept of functional group is thus an aid to understanding chemical reactivity, but not a substitute for working knowledge of TK, that is toxicokinetics, and TD, that is toxicodynamic effects of xenobiotics on the living systems. So this is very important. For a pharmacologist, how pharmacokinetic and pharmacodynamic is important. In the case of toxicologist also, TK and TD are very important. But in addition to this, functional group, motif, particularly if you look into Derek, Sarah, whatever the in silico tools right now, what we have, no, how they are giving you the prediction, how by they are going to compare, they are going to break the structure into smaller fragments, and they are going to check into their library of database. Okay, then they will compare it whether we have any particular alert with particular fraction of that particular molecule. Some other video will discuss about direct LASA, how the software is using. I will explain. So pause here. Also read about, as I told you, know, where the methanol metabolism is very different in the case of primates. That is in the case of monkeys when compared to in the case of rodent, that is rats or mice. Okay. Here in the case of primates, even monkey means even mammals will come in the same category. So methanol is metabolized by alcohol dehydrogenase, whereas in the case of rodents no catalase, but in the case of human beings catalase, if you look into any alcohol no, catalase is also involved in the metabolism of alcohol, but how much? Only 2%. In the previous video we have discussed only 2% of the metabolism is taking place by catalase. Majority of the metabolism of alcohol is taking by alcohol dehydrogenase. Some part is metabolized by CYP2E1 enzyme, then some part, that is last part, later part, catalase. Why catalase is made? Because catalase, in order to metabolize the alcohol, it need hydrogen peroxide. H2O2 in our body is less. So that particular pathway cannot be possible in the case of either mammal or monkey or primate. Whereas in the case of rodents, the primary pathway is catalase. That is the concept you have to remember. Okay. And what here formaldehyde dehydrogenase is involved. In our case, aldehyde dehydrogenase is involved. And finally, what it is forming is limited H4 folate is there and carbon dioxide is there. So this is the histopathology section of the kidney, which is affected by oxalic acid, and it is affecting your renal tubular cells. Okay, always when you are reading kidney toxicity, you should see whether it is affecting glomerulus, whether it is affecting PCT, DCT. These are very, very important. So these are the rods and cones which are affected by the formic acid, toxic metabolite of methanol. So hope from this video you have understood about the oxidation. First we have discussed about the rate of oxidation, the elimination of the alcohol, whether it is following first order kinetics or zero order kinetics. And next we have understood about the polarity nature of the alcohol, means ethanol, primary, secondary or tertiary, how the functional group is responsible for, and how the primary or secondary means multiple step of oxidation which is ending up with the oxalic acid or formic acid, and what are the target organs, whether it is eye or whether is it kidney. Okay, thank you so much. Be curious. For any questions you can always write a mail to arya.priyanka18@gmail.com. All the best for your exam.